In this lecture, we will shift focus from the two goods model, which had only a single consumer and two goods, to a model with an arbitrary number of consumers and goods. We will then refocus our attention to the demand of one of these goods. We will call this model the market demand model. Exactly which individuals we consider doesn't really matter. It could be all individuals in a country or a city or any other collection of individuals. Here is a summary of the market demand model. We now have many goods and they are all infinitely divisible. All prices are fixed. Again, by fixed we mean that individuals are unable to influence prices by, for example, haggling or consuming large quantities. We have many individuals, and even though preferences differ between individuals, all preferences are well behaved. We use the symbol X with a subscript I and a superscript L to denote the demand of good L from individual I. We have no bad goods, so the demand for all goods is greater than or equal to 0 for all individuals. Each XIL will depend on all prices as well as the income of the individual labeled as individual L. As before, there is no time in this model, and it's best to think of everything happening at a particular point in time. All individuals are presented with a number of goods with given prices. Each individual has an income, and based on her preferences, she can express her demand for each good. All this happens at a single point in time. Even though there is no time in the model, when we apply this model to an actual problem, we typically view demand and income as flows, for example, as a process repeated once a month. What we label as a price for a good could be, for example, the monthly rent of an apartment. If we sum the demand for a particular good over all the individuals, we get the total demand for this good, which we can denote by uppercase XL. Total demand is also called the market demand or the aggregate demand. Total demand will depend on prices as well as all income. Let's demonstrate the relationship between the individual demand functions and the aggregate demand function and their dependence on price, holding all other variables constant in a picture. To simplify things, let's say that we have only two individuals. It doesn't matter which good we look at, so I'm simply labeling my x-axis by Q for quantity. On the y-axis we have the price of the good under consideration. Here is the demand curve for individual 1, and here is the demand curve for individual 2. The second individual has a higher demand at all prices. The length of this green arrow is the demand from individual 1 at the price where the arrow intersects the p-axis. If we move this arrow horizontally to the demand curve for individual 2, then the market demand at this price can be found at the end of this arrow by going straight down to the q-axis. We can do the same thing at different prices. By connecting the tip of all such green arrows, we get the market demand curve. The market demand curve is the horizontal sum of the individual demand curves. It should be clear how to generalize this idea for an arbitrary number of individuals. We simply add all the individual demand curves horizontally. We must add them horizontally since quantity is along the horizontal axis.